To provide power and data connectivity to pre-wired seating systems, several steps must be taken focusing on safety and code compliance. Firstly, determine the feed source. Locate the main electrical panel that will provide power to the seating units and determine the location of the data source such as a network switch or router. Secondly, plan the cable routing, ensuring the power and data cables are concealed and protected. Consider using cable trays or conduits to keep cables organized and prevent tripping hazards. Next, prepare the box. Install a single-gang electrical box with a divider into an accessible location near the seating units. The box should be large enough to accommodate the receptacles, wire nuts, and any additional connectors. Cut an opening in the divider for the data cable to pass through. Then wire the box. Connect the power wires to the receptacles and the data cable to the desired connector, for example, an RJ45. Use electrical tape and wire nuts to secure the connections. Test the power and data connections to ensure they are working correctly. Install faceplates over the box to conceal the wiring and provide a clean appearance. Ensure the faceplates match the existing receptacle covers. The size of the box will depend on the number of receptacles and the type of data connector being used. A standard single-gang box is typically 4 inches by 2 inches by 2.5 inches. Consider using a larger box, such as 4 inches by 4 inches by 2.5 inches if more space is needed for additional connectors or wire management. Use a divider that is designed for electrical boxes with a thickness of 1/2 inch or 3/4 inch. This will ensure that the power and data cables are separated and protected. Consider some additional tips as well. Use high-quality materials and follow proper electrical code requirements. Clearly label the cables and connections for easy troubleshooting. Test the system thoroughly before putting it into service. Consider using a surge protector to protect the equipment from electrical surges. When selecting materials, use Cat5 cables, power wires rated for 120 volts, a single-gang electrical box with a divider, receptacles to match existing units, faceplates, electrical tape, and wire nut. When installing the electrical box, ensure that it complies with all local and national electrical codes. The National Electrical Code, or NEC, provides guidelines for box fill calculations to ensure that the box is not overcrowded. The number and size of conductors, devices such as receptacles, and internal clamps all contribute to the box fill calculation. Refer to NEC section 314.16 for specific requirements. For example, each conductor counts towards the box fill based on its size. A number 14 American wire gauge conductor requires 2 cubic inches of free space, while a number 12 American wire gauge conductor requires 2.25 cubic inches. Device yokes, such as those for receptacles or switches, count as 2 conductors based on the largest conductor connected to them. Internal cable clamps also count as 1 or more conductors depending on their location. Grounding conductors collectively count as a single conductor. Once the total cubic inch volume required by the conductors and devices is calculated, the electrical box must have an internal volume at least as large as this calculated value. Electrical boxes are marked with their cubic inch capacity. Using an undersized box can lead to overheating and potential fire hazards. Consider using a deeper box or a larger box if necessary to meet the NEC requirements. Proper grounding is critical for electrical safety. The grounding conductor provides a low impedance path for fault current to return to the source, which allows the overcurrent protection device, such as a circuit breaker, to trip and clear the fault. The grounding conductor must be properly sized according to NEC Table 250.122, based on the rating of the overcurrent protection device protecting the circuit. For example, a 20 amp circuit requires a number 12 American wire gauge copper grounding conductor. The grounding conductor must be connected to the metal enclosure of the electrical box, the grounding terminals of the receptacles, and any other metal parts that are likely to become energized. Use green insulated wire or bare copper wire for the grounding conductor. Avoid using the neutral conductor as a grounding path, as this can create a shock hazard. The data cable should be properly shielded to prevent electromagnetic interference from the power wires. Use a shielded Cat5 cable and ensure that the shield is properly grounded. Maintain physical separation between the power and data cables to minimize interference. The divider in the electrical box helps to maintain this separation. Avoid running the power and data cables parallel to each other for long distances. If they must run parallel, maintain a minimum separation of 12 inches. Use cable ties or straps to secure the cables and prevent them from sagging or getting tangled. When making connections, use high-quality connectors and terminals. Ensure that the connections are tight and secure. Use wire nuts that are appropriately sized for the number and gauge of the wires being connected. Use electrical tape to insulate the connections and prevent shorts. When installing receptacles, use tamper-resistant receptacles, especially in public areas where children may be present. Tamper-resistant receptacles have internal shutters that prevent foreign objects from being inserted into the slots. These receptacles provide an additional layer of safety. When testing the system, use a multimeter to verify that the voltage and current are within the specified limits. Use a cable tester to verify that the data cable is properly connected and that there are no shorts or opens. Verify that the grounding system is properly installed and that the resistance to ground is low. Document the wiring configuration and keep a record of all tests performed. Provide clear labeling for all cables and connections to facilitate troubleshooting. Train personnel on the proper use of the system and the potential hazards of working with electricity. Follow lockout-tagout procedures when performing maintenance or repairs on the electrical system. Disconnect the power source and verify that the circuit is de-energized before working on it. Use appropriate personal protective equipment such as insulated gloves and safety glasses. Avoid working on electrical systems in wet or damp conditions. If the seating system includes any electronic equipment, such as amplifiers or control panels, ensure that the equipment is properly grounded and protected from electrical surges. Consider using a dedicated circuit for the seating system to prevent overloading the existing circuits. Consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. A professional electrician can help with designing the system, selecting the appropriate materials, and performing the installation safely and correctly. Regular inspections and maintenance are essential to ensure the continued safe and reliable operation of the system. Inspect the wiring, connections, and receptacles periodically for any signs of damage or wear. Replace any damaged or worn components promptly. Test the grounding system annually to ensure that it is still functioning properly. Keep the area around the seating system clean and free of obstructions. Avoid storing flammable materials near the electrical equipment. Provide adequate ventilation to prevent overheating. By following these guidelines, the power and data connectivity to the seating systems can be implemented safely and effectively. This will enhance the functionality and usability of the space while ensuring the safety of occupants. In addition to the physical wiring and connections, consider the overall design and layout of the seating system. Ensure that the seating is arranged in a way that allows for easy access to the power and data connections. Provide adequate space for users to plug in their devices and connect to the network. Consider using flexible conduits or cable management systems to route the cables from the electrical box to the seating units. This will allow for easy repositioning of the seating without having to rewire the system. When selecting the seating unit, choose models that are specifically designed for use in public spaces. These units should be durable, comfortable, and easy to clean. They should also meet all applicable safety standards. Consider the aesthetic appearance of the seating system and choose materials and finishes that complement the overall design of the space. Coordinate the color of the faceplates and receptacles with the surrounding decor. The seating system should be integrated seamlessly into the space and should not detract from the overall aesthetic appeal. When planning the power and data distribution for the seating system, consider the future needs of the space. Anticipate potential changes in technology and usage patterns. Design the system to be flexible and adaptable to future requirements. Provide extra capacity in the electrical box and cable pathways to accommodate future expansion. Consider using modular components that can be easily added or removed as needed. By taking a proactive approach to planning and design, a seating system can be created that will meet the needs of today and the challenges of tomorrow. Finally, remember that safety is always the top priority. Never take shortcuts or compromise on safety in the pursuit of cost savings or convenience. Always follow proper electrical code requirements and consult with a qualified electrician if you have any doubts or questions. A properly designed and installed seating system will provide years of reliable service and will enhance the enjoyment of the space for all who use it.